All right, so you tell me, okay, Zaki, you know what? Let's fix the critical value then. Let's change the significance level. Let's change the confidence level, right? So let's do it. Let's move it from 0.1 to 0.06. Because now we're letting in only 10% of the drunk people. And you tell me, Zaki, this is a great solution. We're not going to have that many drunk people in our club. Well, the problem is that now we're kicking away 30% of the sober people, So there's no way to win. The only way to win that they talk about in the book is to increase your sample size. Because look, when you increase your sample size, and the way that we're going to increase the sample size here is literally by getting more molecules of blood, okay? So let's say you have 1 milliliter of blood, okay? If you get 10 milliliters of blood, slightly bigger sample, people are going to probably faint, but at least your measure is a little more accurate. Look, because the distribution is sort of getting narrower, right? Because what's happening is your distributions are getting narrower and narrower as you increase sample size. So here, it's much better. So notice how the point estimates stay the same, right? So this is the point estimate of H0, which is 0, and this is the point estimate of H1. Look at this. It stays the same, okay? But notice how the critical value is shifting with the null hypothesis. Look, the critical value here for 95% used to be 0.1. With a 10 milliliter of blood is 0.7, and here it's 0.4. So that's what you're doing. You're shifting your critical value, right, without increasing the chance of a type 1 error, right? Because here we're still kicking away 5% of the sober people, which is inevitable when you're working at a 95% confidence level. But we're letting in only 1% of the H1 people, only 1% of the drunk people. So that's how we fixed it. All right, so the conclusion is that increasing sample size increases these three things: precision, distribution width, and standard error. We're going to talk about them. So increasing sample size increases precision because your interval is getting more precise, right? Your interval for your H0 is getting more precise. For H1 is getting more precise. So more precise. It's getting narrower, right? Because the distribution was wider and now it's narrower. Great. And as a consequence of that, you're getting a smaller standard error because remember, the standard error is the measure that you have here between the average and the first z-score. So look at the standard error getting smaller and smaller as we increase sample size. Okay, smaller standard error. Cool. Reminder, the distribution of your sample, the sample distribution, uses the standard deviation to shape its distribution. But your sampling distribution, whether it's derived or ideal, will use the measure called standard error. In practice, it's the same thing, but we call them different, just to clarify that we're talking about either a sampling distribution or just a regular distribution in your sample. Now, decreasing sample size. What happens if you decrease sample size? So if you decrease sample size, your distribution goes the opposite direction. It's less precise because it's wider. And as a consequence, you also get a larger standard error.